The obvious equivalent fractions, such as these, don't require a whole lot of thought. You just know what to do in order to get from one to another. But there is actually a rule that you can use to get from one fraction to another and make them both equivalent. And it goes like this. To obtain an equivalent fraction, multiply the original by a fraction, sorry, I lost my place, equal to 1. Well, what makes a fraction equal to 1? Well, the numerator and denominator are the same, right? So let's take, for example, 3, 6. And let's say I want to rename it something that has a denominator of 12. I realize most of you can figure in your mind what you got to do that. But what must I multiply 3/6 by in order to change this to a new thing with a 12? Grace? She's right. 2/2 is the fraction equal to 1 in this case, which would then give me 6/12, right? That's the entire lesson in a nutshell. So let's go through the various examples using this asterisk rule here. First of all, let's just say example 1. This one is the easy version. Write 2 fractions that are equal 15/18. 15/18. Well, the rule above says if I multiply both numbers by the same thing, I will create an equivalent fraction. Anybody want to give me something you want to multiply it by? Probably something easy, something I can do in my head. Ben? He says multiply each piece by 2/2. Good choice. Which gives me 30/36? That's great. If I start multiplying by 3 and 4, though, that might be kind of hard on me. That's a lot of math. I want to challenge you with something to add to this. Not only can you multiply the original 1 by a fraction equal to 1, you can also divide your original fraction by something that equals 1. Now the key here is knowing what both of these are divisible by. So we came up with one equivalent fraction. Let's write another one using that extra thing I just shared with you. What number is both of these divisible by? Ellie?
3.
So that will be the fraction we'll use, 3/3, right? 3/3. So we multiplied by a fraction equal to 1, and you could keep doing that. You could have multiplied it if you wanted, but that's too much math. I don't want to do all that. Dividing it gave us 5/6. So these are just two fractions that equal that. 30/36, 5/6. By the way, there's an infinite number of answers. Okay, you could multiply both of these by 10 and get 150/180. That would have been acceptable. You could have multiplied it by 100. whatever you want to do, but I want you to recognize that you don't always only have to multiply by a fraction equal to 1. Sometimes it's simpler to divide by a fraction equal to 1. Quicker to do, right? By the way, this one is in what is said to be simplest form. Simplest form in our world means it's reduced and cannot be divided by any other numbers other than 1. There are no other factors that these two numbers share, therefore it's reduced. This is not, they could both be divided. This was not, we know they could be divided. So these are non-simplified, so to speak, but this one was simplest or simplified. Most of what you guys do when you simplify, you do in your head. You wouldn't necessarily be able to explain to me how you do it. Maybe you would. I don't know, maybe you would. But in example 2, what I'm about to show you is how to explain it. If I say to you, write this particular fraction, 25 over 40, in simplest form. By the way, your textbook will probably say, as time goes on, simplify. When I mark them wrong, if you didn't reduce it, I would write simplify. Anyway, to simplify, what you need to find is the greatest common factor of both numbers. And divide by that. So you guys already probably know what that is, but I'm going to show you anyway. 25's factors are 1 and 25. These are the factors. This isn't prime factorization. And 5 times 5. 40's factors are 1 and 40, 2 and 20, 4 and 10, 5 and 8. They share several, but 5 is the greatest of what they share. Take the fraction, divide it by that fraction equal to 1, and you have now renamed your fraction into simplest form. You've already been doing this, guys. When you've been told to reduce, this is what you've been doing. You just haven't necessarily done it using these words. Doesn't make the process any more difficult. Let's do another one. Do this one with me. 2742. Might not be as easy to know what the greatest common factor of that is. You want to list out the factors, or is there another way we can quickly find the greatest common factor, also known as prime factorization? Let's do that. We're going to prime factor both of these, and the product of what they share will be the greatest common factor. So 27 is 3 times 3 times 3. 42 is 2 times 21, 3, 7, 7, 1. 2 times 3 times 7. What do they share, folks? 3 is right. They share a 3. So we're going to divide by 3. Lost my place. Thank you. Do 9 and 14 share any other factors other than a 1? No. Factors of 9, 1, 9, and 3. Factors of 14, 1, 14, 2, and 7. Nothing else is shared other than the 1. Therefore, 9/14 is now the simplified version of that. If I were to ask you a question about, say, trying to think of a different one. Here we go. I got one. This is similar to the book's example 3, only this is my example. Example 3. Tom served lunch to 42 people, of whom 28 ordered burgers. Give me a fraction in simplest form representing people with burgers out of the total. In other words, give me the ratio of who ordered burgers out of the total. You know, we've done this before. There's 12 boys in a class of 20. Give me the ratio of boys to class, 12 to 20, and you would reduce it. You guys did that in 6th grade. Same exact thing. Looks to me like 28 were burger lovers out of 42, right? 6th grade strikes back. Greatest common factor of 28 and 42. Anybody have an idea? It's not 7 if you're thinking it's 7. Noah. The answer is 2/3, right? But what was the greatest common factor that got you there? Ma'am. 14's right. If you divide both pieces by 14, you will find that 2/3 of Tom's customers ate burgers. 2/3 ate burgers. Example 3 analyzes something else. Today's homework, number 28, involves bones. Same idea. Quantity that they're talking about out of the total. Human body bones. Okay? I don't want to see question marks and IDK. I want to see, I'm trying, so I'm actually going to figure this out because I care. That's what I want to see. Example 4. Example 4, this is where everybody starts to freak out. Here's a fraction, 16b times c cubed over 24b squared c. Simplify this. Well, how in the world do I do that? How in the world do I do that? The book shows you one way. I'm going to show you one that's slightly different. The way I do it is I break it here. Can you simplify 16 over 24 without throwing your pencil on the floor? 16 over 24, what do you get, 2/3? Okay. So 2 is my numerator, 3 is my denominator, right? Now, where it gets tricky is all those letters. To deal with the letters, factor them out. This is bc cubed. The denominator is b squared c. Okay, so the way I do it, first I do the numbers, and then factor out the letters. Reduce wherever you have a matching one in the numerator and the denominator. A pair of b's cancel each other out because b divided by b is 1. Anything divided by itself is 1. Cancel out a pair of c's because anything divided by itself is 1. This reduces the fraction, leaving the numerator c squared and the denominator b to the first. This cannot be reduced anymore because neither the 2 and the 3 share anything other than a 1, and c don't share anything with b other than a 1. I want to give back. Do another one just like that. We're going to do another one just like that one. Example 4. We're going to try this one with me. 6b 24b squared. Same kind of thing. Cut the number away from the b's. How would 6 24s reduce? Emma, what does 6 over 24 reduce to? 1/4 is right. Now, deal with the b's. B is in the numerator. BB is in the denominator. Anywhere there is a matching set, cancel them. That means that nothing in the variable department goes back up there. There's nothing left in the land of variables. But there is still a b left in the denominator, and it lives there. Okay? It will go there.